Today we're going to be covering something called electric potential energy and then compare that to something called potential difference, which is also known as voltage. Electric potential energy is basically when we build up a charge. So for example, if I'm rubbing the rubber rod with fur, the fur is donating electrons to the rubber rod, and that builds up a charge. That buildup of charge is a stored electric potential energy. Now, the electric field between the negative rod and the newly positive fur exists because there is attraction between the negative electrons on the rod and the positive fur. This stored up energy, or electric potential energy, makes the electrons want to go back to a lower energy level near the positive charge. We can compare that to something like a high water reservoir. A high water reservoir would pump water out of a pond and up into some kind of container. Now, by pumping up the water, you're doing work on the water. And by doing the work on the water, you're giving that water higher up energy. That stored energy we call potential energy. Well, if we compare this one where we just pump up the water to a reservoir versus this one where we pump it up even higher to a higher reservoir, the energy that went into bringing it up there comes out. So if you bring even more energy to put it in there, even more energy comes out. Electrons are kind of like this. When you build up a charge and do work on the electrons, they have an electric potential energy or a stored amount of energy. And then when they move back, they want to release that energy, that potential energy, in order to get to a more stable environment. So if you rub a balloon on your hair, we know that the hair gives off electrons and it goes towards the balloon. Now you're pumping electrons away, giving them higher electric potential energy. Because of that, the energy goes up and they want to come back to the hair, which makes the hair and the balloon seem to want to stick together. That form of attraction happens because of the electric potential energy. Now, in order to get those electrons away from their normal spot, they have to do work, or something has to do work on it, I should say, by pushing that charge against an electric field that's there and moving it somewhere it might not go. So we can think of it as the amount of work done on the charge gives that charge its potential energy. So if we define electric potential energy, it's basically the energy a charge has because of its new location in the electric field. In most cases, you're going to have to do work on it to move it to that place. But when you do, and it gets a higher electric potential energy, it means that the work you did, the energy you put into it, gave it its stored electric potential energy. Now, if we looked at something slightly different, the electric potential difference sounds similar to electric potential energy, but it isn't. It's talking about the difference between the positive and negative end in an electric field. You may have heard of electric potential difference be called voltage. And between online and worksheets and textbooks and that, you may hear it called electric potential or potential difference. So there's literally 4 different names for the same idea. But anyways, we know that work can be done in order to move a test charge from one side of the electric field to the other. So here's my electric field, positive and negative side. If I have a negative electron here, if I would have to push it to move it towards the negative side, or it would naturally flow to the positive side. But because it's closer to the negative end, it has a greater amount of electric potential energy. And because of that, it'll want to lose some of that energy and go over to the positive side. Now we can call that difference in electric potential energy the potential difference. And again, another word for that is voltage. But to find that, we need to figure out how much work was done on the charge divided by the object's charge. By doing so, that gives us the voltage. Think of potential difference or voltage as how bad that charged particle wants to go to the other end or the other side of the electric field. It has this stored up energy, just like the water high up in the air did, right? And that stored up energy, it wants to release it. So electrons that have charge built up want to go to the other end, the positive end. They want to get away from all the other negative charges, all right? So we can figure out how strong that is, that voltage, by taking the work divided by the charge. So if you do work divided by charge, you would get joules per coulomb, but we can make that even more simple by just calling it a volt. But remember, Only if you have a difference in potential energy does it matter to us, because then there can be a flow of electricity when there is a difference. And we'll talk about that soon with batteries. Now, how strong your voltage is, meaning how different are your two ends causing different electric potential energies, that's also related to the electric field. And it's no surprise, the stronger the voltage, the stronger the electric field is going to be. So as voltage goes up, so would the electric field. Now, the electric field can be determined by voltage divided by its distance in meters. So volts divided by meters. And that tells you how strong the electric field is, and it is, of course, related strongly to the voltage. It makes sense. If a voltage is high, it really wants to go from one end to the other. By it, I mean an electron really wants to go from the negative side to the positive side. And that makes sense. If it's really getting pushed through, then the electric field must be strong as well. So to end our discussion, let's think about if we take a wool cloth and rub it on a piece of hard wax. Wool cloth is from a sheep, so that's like fur, and we know fur gives off electrons. So if we have this negative charge on the wax, and we've created this positive charge on the wool, then we've created this electric field, right? And that electric field happened because of the potential difference, the voltage, meaning the difference in the positive and the negative end. If I put a charge that was positive towards this side, I'd have a large amount of electric potential energy, and it would naturally want to move to the negative side, all right? Vice versa, if I put a negative charge here, it would naturally want to move to the positive side. That high electric potential energy can help figure out just how much potential difference there is, and therefore how much voltage. So between a wool cloth and wax is probably not a super strong electric field, but you can see how there's different electric potential energies depending on the location of different charges, positives and negatives. And those different electric potential energies causes a potential difference, which causes voltage. All right, so we're going to wrap that up. Do your practice and your homework with the worksheets. Those concepts will kind of be defined here and not so long as you give it a shot. So good luck and thanks for listening.